Equilibrium is a reversible reaction, meaning as reactants are reacting to give you products, at the same time products decompose and give reactants back. This forward and reverse reaction continuously takes place, and there are few properties that you need to respect in order to have equilibrium. First, your system needs to be closed. What do we mean by closed? Meaning no mass or energy should be lost or gained. So if you have a reaction vessel, especially in terms of gases, immediately put a cork on it, close the flask so the gases cannot escape. Also, we try to keep it as insulated as possible so there is no heat rise or decline. It doesn't get cold or hot. The other two properties that happen is concentrations of reactants at equilibrium is constant, and concentration of products at equilibrium is also held constant, but they're not equal to each other. So I put bracket to represent concentration, R for reactant, subscript EQ, and I say it's constant. Once equilibrium is established, otherwise it's changing. And same thing happens to product. So concentration of products at equilibrium is also held constant. Not equal to each other, remember that for sake of answering questions. So let's just see, I have a graph here of concentration versus time. So at beginning you only have reactant in the vessel, they start reacting, and the concentration of the reactant is going down because it's being consumed. And then there becomes a point of time that it's just steady, it doesn't change. So I put R in bracket to represent concentration of reactants. At the same time as reactant took place and started reacting, product starts decomposing, and they also will come to a point of time and their concentration remains constant. And I call this product. Now the first moment that the steadiness is coming to life is the moment that we are going to say equilibrium has come to life. So from here on, from this time on, equilibrium has been established. The two concentrations remain constant, then again not converging, therefore they're not equal to each other. And you have to sort of remember. Before this line, the concentrations are both changing. Now, the last property is rate of forward reaction is equal to rate of reverse reaction at equilibrium. The mole per decimeter cube per unit time of reactants is equal to mole per decimeter cube of products. So this goes back to your topic of kinetics. So if this is my reactants, at beginning it starts decomposing extremely fast, and eventually it slows down, so the rate goes down, and there is no change in the rate. So I write this forward reaction. Now let's just compare it to the reverse reaction. There was no product, it comes to life, immediately it starts reacting extremely fast, so there is a steep slope, and then gradually they come and they converge on the same line. So this is reverse. Now the moment they converged is the moment that you can also say is equilibrium, and it's equal to the same moment of time as the concentration. So this is also equilibrium. So equilibrium is a reversible reaction. Equilibrium is dynamic. The system has to be closed. By closed we mean mass and energy should not be lost. Concentrations of reactants and products at equilibrium are constant, not equal to each other. Remember that point, please. And the last point is rate of forward reaction equals rate of reverse reaction only at equilibrium and at equilibrium on. This rate does not change with unit time anymore. They are steady, and constantly you are reacting, constantly you go forward and backward, but it's the same proportionality of time.